Hello doctor and my fellow friends. Today we are group 7 would like to present our mini project about water supply to a community center. First of all, I would like to introduce my group members. Chu Kai, Lee Yongji, Satish Kumar, myself and Teo Chun Seng. To start our presentation by introduction. First, the role of the water supply to the system to provide the potable water to the consumer at suitable pressure level. The main concern of piping system is to ensure the water quality and the consistent supply of water to the community. Therefore, this project is evaluate the most sustainable and environmentally friendly option to build this piping system and the pump selection. As you guys see in the slide, this is our design of our water pumping system to the community center. Next is methodology. Even though there is a lot of component in methodology, we focus on two main component only, which is pump selection and valve selection. We have chosen the centrifugal pump in our piping system because it has rotation effect caused by impeller. It also can install horizontally or vertically with the pump shaft. It also has few benefits, cheap, easy to install, less maintenance is needed and hard to break. Next is the valve selection. We have chosen the globe valve in our piping system. It also known as throttle valve. It consists of movable disc and stationary ring. It is designed to handle flow either direction. And the last thing is it handles the higher pressure drops than valve, but may be used the pressure drop through the valve is not critical.
Hi, my name is Sun Seng. Before starting the calculation, our group have made some assumptions. After this, by using the formula Q equal to V times A, the volumetric flow rate is 0.08836 meter cube per second throughout the water pump system. By using the Bernoulli equation, the pressure at point 2 is 284.474 kPa. After we determine the Reynolds number of the flow in part 1, then we use the explicit Helen equation to find the friction factor of the major loss, which are 0.01215. After we find the total friction coefficient in part 1, the total head loss in the part 1 is 27.56 meter. By using the same method, the pressure at point 3 is 1482 kPa, while pressure at point 4 is 2215.54 kPa.
Water flow from filter 1 to water tank through pipe 2. After knowing it is turbulent flow, friction factor for major loss is calculated. Then the friction coefficient for minor loss is determined from the types of fitting along the pipe 2, which are rounded pipe exit, flank 90 degree smooth band, globe valve, and well-rounded pipe inlet. Since we apply a valve to control the pressure of the water, so the pressure inlet to the water tank is adjusted to 300 kPa. Then pressure at point 6 and 7 were calculated by using Bernoulli's equation. Then water flow to inlet of filter 2 passes through pipe 3. The total head loss in pipe 3 calculated is 16.79 meter. By applying the head loss through pipe 3, the pressure at point 8 and 9 were calculated.
Then water flow to inclusion 1 through pipe 4. The total head loss of pipe 4 is 5.5 meter. By applying the head loss through pipe 4, the pressure at point 9 and 10 were calculated. There are 3 outlets at junction 1. At the first outlet, water flow to swimming pool through pipe 5 and the heat loss of pipe 5 is calculated. Heat loss of pipe 5 is 2.15 meter. By applying this value, the pressure at point 11 and 12 are calculated. The water flow to inlet of junction 2 through pipe 6. The head loss of pipe 6 is 5.5 meter. Since there are 2 inlets in junction 2, so point 13 has 2 pressure. The first pressure is calculated by using the heat loss of pipe 6. At second inlet of junction 1, water flow to wading pool through pipe 7. The heat loss of pipe 7 is calculated. Using the heat loss of pipe 7, the pressure at point 14 and 15 were calculated. Water flow to second inlet of junction 2 through pipe 8 and the heat loss of pipe 8 is calculated. Note that the second pressure at point 13 is calculated. The total pressure at point 13 is calculated by sum up the first pressure and second pressure. Third inlet of junction 1, water flow to restaurant through pipe 9 and the heat loss of pipe 9 is calculated too. And using the heat loss of pipe 9, the pressure at point 16 and 17 were calculated. At the outlet of junction 2, the water is pumped to water tank through pipe 10 and the heat loss of pipe 10 is calculated. Using a heat loss of pipe 10, the power of pump is calculated, which is 191.85 kW.
In conclusion, globe valve is used to maintain the workflow, and the pump is used to restore the water. Therefore, our water delivery system design is good as we can minimize the head loss during the delivery and hence increase the efficiency of the pump. Thank you.